Misconceptions about batch size are incredibly common. Hospital pharmacies often deliver big batches of medicine to patient floor once a day because it's efficient. A single trip, right? But many of those meds get sent back to the pharmacy when a patient order have changed to the patient is moved or discharged, causing the pharmacy staff to do lots of rework, reprocessing, or trashing of mats. Delivering smaller batches every 4 hours reduce the total workload for the pharmacy and ensure that the right mats are the right place when needed. Hospitals lab blood collections often are done in early batches. Phlebotomists collects blood for an hour from multiple patients and then send or take all the samples to the lab. This adds to turnaround time for test results and can harm test quality. It has become common for hospitals to bring small batches, two patients, or a single patient flow of specimens to the lab, even if they have to hire an extra phlebotomist or two to do so because the total system cost is lower. Pull, don't push. Pull, don't push. Let's say you are out for a drive, pondering the merits of a small batches and find yourself accidentally putting a dent in your new 2011 blue Toyota Camry. You take it into the dealership for repair and wait to hear the bad news. The repair technician tells you that you need to have the bumper replaced. He goes to check their inventory levels and tells you he has a new bumper in stock and they can complete your repair immediately. This is good news for everyone. You because you get your car back sooner, and the dealer because they have a happy customer and don't run the risk of your taking the car somewhere else for repair. Also, they don't have to store your car or give you a loaner while they wait for the part to come in. In traditional mass productions, the way to avoid stock out, not having the product the customer want, is to keep a large inventory of spares just in case. It may be that the blue 2011 Camry bumper is quite popular, but what about last year models or about model from 5 years ago? The more inventory you keep, the greater the likelihood you will have the right product in stock for every customer. But large inventories are expensive, and because they have to be transported, stored, and tracked, what if the 2011 bumper turns out to have a defect? All the spares in all the warehouses instantly become waste. Lean production solves the problem of stock out with a technique called pull. When you bring a car into the dealership for repair, one blue 2011 Camry bumper gets used. This creates a hole in the dealership inventory, which automatically causes a single to be sent to a local restocking facility called the Toyota Parts Distribution Center (PDC). The PDC sends the dealers a new bumper, which creates another hole in inventory. This sent a similar signal to a regional warehouse called the Toyota Part Redistribution Center (PRC), where all part suppliers ship their products. That warehouse signal the factory where the bumpers are made to produce one more bumper, which is manufactured and shipped to the PRC. The ideal goal is to achieve a small batch all the way down to single piece flow along the entire supply chain. Each step in the line pulls the part it needs from the previous step. This is the famous Toyota just-in-time production model. When companies switch to this kind of production, their warehouse immediately shrink as the amount of just-in-case inventory call work in progress WIP inventory is reduced dramatically. This almost magical shrinkage of WIP is where lean manufacturing gets its name. It as if the whole supply chain suddenly went on a diet. The startups struggle to see their work in progress inventory when factories have excess WIP. It literally piles up on the factory floor because most startup work in work is intangible. It's not nearly as visible. For example, all the work that goes into designing the minimum viable product is until the moment that product is shipped. Just WIP inventory incomplete design, not yet validated assumption, and most business plans are WIP. Almost every lean startup technique we have discussed so far work its magic in two ways by converting push method to pull and reducing batch size. Both have the net effect of reducing WIP. In manufacturing, pull is used primarily to make sure production processes are tuned to level of customer demand. Without this, factories can wind up making much more or much less of a product than customers really want. However, applying this approach to developing new product is not straightforward. Some people misunderstand the lean startup model as simply applying pull to customer want. This assume that customer could tell us what product to build and that this would act as a pull signal to product development to make them. As was mentioned earlier, this is not the way the lean startup model work because customer often don't know what they want. Our goal in building product is to be able to run experiment that will help us learn how to build a sustainable business. Thus, the right way to think about the product development process in a lean startup is that it is responding to pull requests in the form of experiment that need to be run. As soon as we formulate a hypothesis that we want to test, the product development team should be engineered to design and run this experiment as quickly as possible using the smallest batch size that will get the job done. Remember that although we write the feedback loop as build, measure, learn, because the activities happen in that order, our planning really works in the reverse order. We figure out what we need to learn and then work backward to see what happened, what product will work as an experiment to get that learning. Thus, it is not the customer but rather our hypothesis about the customer that pulls work from product development and other functions. Any other work is waste. Hypothesis pull in clean tech. To see this in action, let's take a look at Berkeley based startup Alphabet Energy. Any machine or process that generates power, whether it is a motor in a factory or a coal burning power plant, generate heat as a byproduct. Alphabet Energy has developed a product that can generate electricity from this waste heat using a new kind of material called a thermoelectric. Alphabet Energy thermoelectric material was developed over 10 years by scientists at the Lawrence Berkeley National Laboratory. As with many clean technology products, there are huge challenges in bringing a product like this to market. While working through its leap of faith assumption, Alphabet figured out early that developing a solution for waste thermoelectricity require building a heat exchange and generic device to transfer heat from one medium to another as well as doing project specific engineering. For instance, if Alphabet wanted to build a solution for a utility such as specific gas and electric The heat exchanger would have to be configured, shaped, and installed to capture the heat from a power plant exhaust system. What makes Alphabet Energy unique is the company made a savvy decision early on the research process instead of using relatively rare elements as materials. They decided to base their research on silicon wafers, the same physical substance that computer central processing units CPUs are made from. CEO Matthew Scullin explains our thermoelectric is the only one that can use low-cost semiconductor infrastructure for manufacturing. This has enabled Alphabet's Energy to design and build its product in small batches. By contrast, most successful clean technology startups have had to make substantial early investment. The solar panel provider SunPower had to build in factories to manufacture its panel and partners with installer before becoming fully operational. Similarly, BrightSource raised $291 million to build and operate large-scale solar plants without delivering a watt in single customer. Instead of having to invest time and money in expensive fabrication facilities, Alphabet is able to take advantage of the massive existing infrastructure that produce silicon wafer for computer electronics. As a result, Alphabet can go from product concept to holding a physical vision in its hand in just 6 weeks from end to end. Alphabet's challenge has been to find the combination of performance, price, and physical shape that is the match for early customers. Although its technology has revolutionary potential, early adopter will deploy it only if they can see a clear return on an investment. It might seem that the most obvious market for Alphabet's technology would be power plant, and indeed that was the team initial hypothesis. Alphabet hypothesized the simple cycle gas turbine would be an ideal application. These turbines, which are similar to gas engines strapped to the ground, are used by power generators to provide energy for peak demand. Alphabet believed that attaching its semiconductor to those turbines would be simple and cheap. The company went about testing this hypothesis a small batch by building a small scale solution for its customer as a way of learning. As with many initial ideas, their hypothesis was disproved quickly. Power companies have a low tolerance for risk, making them unlikely to become early adopters because it wasn't weighed down by a large batch approach. Alphabet was ready to pivot after just 3 months of investigation. Alphabet has eliminated many other potential markets as well, leading to a series of customers segment pivots. The company current efforts are focused on manufacturing firms, which have the ability to experiment with new technology in separate parts of their factory. This allows early adopters to evaluate the real world benefit before committing to a large deployment. These early deployments are putting more of Alphabet assumption to the test. Unlike in the computer hardware business, customers are not willing to pay top dollar for maximum performance. This has required significant change in Alphabet product, configuring it to achieve the lowest cost per watt possible. All this experimentation has cost the company a tiny fraction of what other energy startups have consumed. To date, Alphabet has raised approximately $1 million. Only time will tell if they will prevail, but thanks to the power of small batches, they will be able to discover the truth much faster. The Toyota production system is probably the most advanced system of management in the world, but even more impressive is the fact that Toyota has built Twitter has built the most advanced learning organization in the history. It has demonstrated an ability to unleash the creativity in its employee, achieve consistent growth, and produce innovative new products relentlessly over the course of nearly a century. This is a kind of long term success to which entrepreneurs should aspire. Although lean production techniques are powerful, they are only a manifestation of a high functioning organization that is committed to achieve maximum performance by employing the right measures of progress over the long term. Process is only the foundation upon which a great company culture can develop. But without this foundation, efforts to encourage learning, creativity, and innovation will fall flat. As many delusions directors of HR can attest. The lean startup works only if we are able to build an organization and adaptable and fast as the challenges it faces. This requires tackling the human challenges inherent in this new way of working. This is the subject of the reminder of part 3, the startup way, people, culture, process, accountability. 10 Chapter 10 Growth. I recently had two startups seek my advice on the same day as types of business. They could not be more different. The first is developing a marketplace to help traders of collectibles connect with one another. These pupils are hardcore fan of movies and anime or comics who strive to put together a complete collection of toys and other promotional merchandise related to the characters they love. The startup aspired to compete with online marketplaces such as eBay as well as physical marketplace attached to convention and other gathering of fans. The second is startup sale database software to enterprise customer. They have a next generation database technology that can supplement or replace offering from large companies such as Oracle, IBM, and SAP. Their customers are chief information officers, CIOs, IT managers, and engineers in some of the world's largest organizations. These are the long lead time sales that require salespeople, sales engineers, installation support, and maintenance contract. You could be forgiven for thinking these two companies have absolutely nothing in common, yet both came to me with the exact same problem. Each one had early customers and promising early revenue. They had validated and invalidated many hypotheses in their business models and were executing against their product roadmap successfully. Their customers had provided a healthy mix of positive feedback and suggestion for improvement. Both companies had used their early success to raise money from outside investor. The problem was that neither company was growing. Both CEOs brought me identical looking graphs showing that their early growth had flatlined. They could not understand why. They were acutely aware of the need to show progress to their employees, investor, and came to me because they wanted advice on how to jumpstart their growth. Should they invest in more advertisement or marketing programs? Should they focus on product quality or new features? Should they try to improve conversion rate or pricing? As it turns, both companies share a deep similarity in the way their business grew and therefore a similar confusion about what to do. Both are using the same engine of growth. The topic of this chapter, where does growth come from? Where does growth come from? The engine of growth is the mechanism that a startup used to achieve Sustainable growth, I use the word sustainable to exclude all one time activities that generate a surge of customer but have no long term impact, such as a single advertisement or publicity stunt that might be used to jumpstart growth but could not sustain that growth for the long term. Sustainable growth is characterized by one simple rule: new customer come from the action of the past customer. There are four primary ways past customer drive sustainable growth. Number one, word of mouth embedded in most product is a natural level of growth that is caused by satisfied customer enthusiasm for the product. For example, when I bought my first TiVo DVR, I couldn't stop telling my friends and family about it. Pretty soon, my entire family was using one. Number two, as a side effect of product usage, fashion or status, such as luxury good products drive awareness of themselves whenever they are used. When you see someone dressed in the latest clothes or driving a certain car, you may be influenced to buy that product. This is also true of so-called viral products such as Facebook and PayPal. When a customer sends money to a friend using PayPal, the friend is exposed automatically to the PayPal product. Number three, through funded advertisement, most business employ advertising to entice new customer to use their product. For this to be a source of sustainable growth, the advertising must be paid for out of revenue, not one-time source such as investment capital. As long as the cost of acquiring a new customer, the so-called marginal cost, is less than the revenue that customer generates. The marginal revenue, the excess, the marginal profit can be used to acquire more customer. The more marginal profit, the faster the growth. Number four, so repeat purchase or use. Some products are designed to be purchased repeatedly either through a subscription plan, a cable company, or through voluntarily repurchase groceries or light bulbs. By contrast, many products and services are intentionally designed as one-time events such as wedding planning. These source of sustainable growth power feedback loop that I have termed engines of growth. Each is like a combustion engine turning over and over. The faster the loop runs, the faster the company will grow. Each engine has an intrinsic set of metrics that determine how fast a company can grow when using it. The three engines of growth we saw in part 2, how important is for a startup to use the right kind of metrics, actionable metrics to evaluate their progress. However, this leaves a large amount of variety in terms of which numbers one should measure. In fact, one of the most expensive forms of potential waste for a startup is expanding time, arguing about how to prioritize new development once it has a product on the market. At any time, the company could invest its energy in finding new customers, servicing existing customer better, improving overall quality, or driving down cost. In my experience, the decision about these kinds of priorities decision can consume a substantial fraction of the company's time. Engine of growth are designed to give a startup a relatively small set of metrics on which to focus their energies. As one of my mentors, the venture capital investor Sean Carolon, put it, startup don't starve, they are always a zillion new ideas about how to make the product better floating around. But the hard truth is that most of those ideas make a difference only at the margin. They are mere optimization. Startups have to focus on the big experiments that lead to validated learning. The engines of growth framework help them stay focused on the metrics that matter. the sticky engine of growth. This brings us back to the two startup that kick off this chapter. Both are using the exact same engine of growth. Despite being in very difficult industries, despite being in very different industry, both products are designed to attract and retain customer for the long term. The underlying mechanism of that retention is different in the two cases. For the collectible company, the idea is to become the number one shopping destination for fanatical collectors. These are people who are constantly hunting for the latest items and the best deals if the company product work as designed. Collectors who start using it will check constantly and repeatedly to see if the new items are for sale, as well as listing their own items for sale or trade. The startup database vendor relies on repeat usage for a very different reason. Database technology is used only as the foundation for a customer owned product, such as a website or point of sale system. Once you build a product on top of a particular database technology, it is extremely difficult to search in the IT industry. Such customers are said to be locked in the vendor they choose. For such a product to grow, it has to offer such a compelling new capability that customers are willing to risk their being tied to a proprietary vendor for a potential long time. Thus, both businesses rely on having a high customer retention rate. They have an expectation that once you start using their product, you will continue to do so. This is the same dynamic as a mobile telephone service provider. When a customer cancels his or her service, it generally means that he or she is extremely dissatisfied or is switching to a competitor's product. This is in contrast to, say, grocery on the store aisle. In the grocery retail business, customer tastes fluctuate, and if customer buy a Pepsi this week instead of Coke, it's not necessarily a big deal. Therefore, companies using the sticky engine of growth track their attrition rate or churn rate very carefully. The churn rate is defined as the fraction of customer in any product who fails to remain engaged with the company product. The rules that govern the sticky engine of growth are pretty simple. If the rate of new customer acquisition exceed the churn rate, the product will grow. The speed of growth is determined by what I call the rate of compounding, which is simply the natural growth rate minus the churn rate, like a bank account that earns compounding interest. Having a high rate of compounding will lead to extremely rapid growth without advertisement, viral growth, or publicity stunt. Unfortunately, both of these sticky startups were tracking their progress using generic identifiers such as the total number of customers. Even the actionable metrics they were using, such as the activation rate and revenue per customer, weren't very helpful because in the sticky engine of growth, these variables have little impact on growth. In the sticky engine of growth, they are better suited to testing the value hypotheses that are discussed in chapter 5. After our meeting, one of the two startups took me up on my advice to model its customer behavior by using the sticky engine of growth as a template. The results were striking: a 61% retention rate, a 39% growth rate of new customer. In other words, in churn rate and new customer acquisition balance each other almost perfectly, leading to a compounding growth rate of just 0.02%, almost zero. This is typical for companies in an engagement business that are struggling to find growth. An insider who worked at the .com era company Pointcast once showed me how the company suffered a similar dysfunction. When Pointcast was struggling to grow, it was Nathila's incredibly success in new customer acquisition, just like this sticky startup, 39% every period. Unfortunately, this growth is being offset by an equivalent amount of churn. Once it is modeled this way, the good news should be apparent. There are plenty of new customers coming in the door. The way to find growth is to focus on existing customer for the product even more engaging to them. For example, the company could focus on getting more and better listing. This would create an incentive for customer to check back. Other alternatively, the company could do something more direct, such as messaging them about limiting time, sales, or special offer. Either way, its focus needs to be on improving customer retention. This goes against the standard intuition in that if a company lacks growth, it should invest more in sales and marketing. This counterintuitive result is hard to infer from standard vanity metrics.